I like that. Sound effects. Okay. So as you can see, we're in module 3. We are done with parabolas for a little bit. Now that we're all experts on parabolas, we don't have to deal with them for too much here in the near future. What you're going to be looking at here at the top is rules of exponents. All right. So a couple vocab words to start with. When you see the word monomial, so that's a prefix that you're probably familiar with in other classes. The prefix tri means 3. A bi means 2, like bicycles, 2 wheels. The prefix mono means 1. So a monomial is one term. And the way we can define that is with just a number. So it could just be the number 6. Or just a variable like x. Or the product of a number and one or more variables. So I could actually do 6 times x. We could really, as long as it's a product, we can really multiply by as many things as we would like. What you wouldn't see is any pluses and minuses. So if there's no plus or no minus, you're just dealing with a monomial, one term. Then when we look at this, there's a couple things we want to define here. When it says a power, that's the exponent is your power. And we don't have it mentioned, but let's talk about it so we use the right vocab. That's our base. So the base is the 5, and then our exponent is your power. So we now go through these. We got a bunch of rules of exponents that we want to now try and keep straight. And these are going to seem very, very easy when we do them one at a time. I guarantee when they're all thrown together, this can kind of make some heads spin a little bit. So the first rule is if we are multiplying, so we're multiplying like terms. And then what do we do with the powers when we're multiplying like terms? So that's what this says. If we are multiplying 2 numbers together, and they have the same base, you are said to add the exponents. So what that means, this answer here would be, and we'll show why here in a second, since I'm multiplying numbers with the same base, 5 and a 5, what this is saying our answer is 5 to the 8th power. We just add the exponents together. Do not do 5 times 5 and try to turn that into a 25. All right, easy for me to say now, but it's very tempting here when you start doing these on your own. Here's why it works out like this. This 5 squared means I have 5 times 5 2 times. The 5 to the 6 means I have 6 5s multiplied together. So now just think about what that would mean. This we know from over time, having done multiplication before. If I now have 1, 2, 3, 4, 5, 6, 7, 8 of these, don't I really just have 5 to the 8th power? So that shows us we're just adding the exponents and we don't want to actually do 5 times 5. It's just 5 to the 8th. Okay? For example, number 2, these are all the same base. So y, and y. So our answer should just be the y, and then you want to add all the exponents. So something we want to get down pat that you're going to see a ton. If I look at this y right here, notice how there isn't an exponent written. We just have to understand that there's a 1 right here. We just don't ever write the 1, but it's implied that there's a 1 there. So when we add up all those exponents, those should add up to be an 8. So we would get y to the 8th power. All right. Example number 3, same thing. We now add a number in front of all of these. So let's do the y's first. So I have a y to the 5th, and then I have this y, which would have a power of 1. Like we've now done a couple of times, you're going to add those exponents. So you're going to get a y to the 6th. Here now is the biggest mistake that I see with all of these. We are adding exponents, but these again are rules of exponents. That doesn't mean we start changing the rules of mathematics overall. I'm still doing a 7 and I'm still multiplying that by a 6. You don't start telling me that's 13. Okay, we don't add the numbers, we only add exponents. 7 times 6 is still 42. So we're going to do 42 and then y to the 6th power. All right, so we've done 3. Try the 4th one and see what we get. See if we're understanding this. All right. How are you today, Alexis? You good?
I got -15 and then x to the third and then y to the 13th.
All right. Do we agree with Alexis there? Tori agrees with you. Getting a few head nods. Yeah, that should be good. That is correct. The numbers you multiply normally, a -3 times a 5 is still a -15. And then the exponents we add. So the x squared, this x had a power of 1. So that has 3 exponents. And then the y to the 7th, y to the 6th add up to be a y to the 13th. All right. That's rule number 1. That's a product of power. So if we're multiplying together, we want to add exponents. The next one is called a quotient of powers. Quotient implies you are dividing or you're dealing with a fraction. So if you look at this example here, if you look at the next 3 problems, those are all fractions. So when we are dividing like terms, so if I am dividing 2 numbers with the same base, we are now going to subtract the exponents. Notice how we subtract. Notice how it's an m minus an n. So it's the exponent in the numerator minus the exponent in your denominator. So what that would simply mean for number 5 is if I have a y to the 6 on top and a y to the 1st in my denominator, I just do 6 minus a 1, and I should have y to the 5th. Now, I kind of want to be just thorough so we understand where all these are coming from. Here's why this works. If I have 6 y's in my numerator, all multiplied together, and I only have 1 in my denominator, wouldn't the y in the denominator cancel out one of the y's in the numerator, leaving me still with 5 y's left over? So that's why it's really just us subtracting. The exponents in the numerator minus the exponents in our denominator. All right? So with that, try number 6. And then what you just want to be careful of, just like up here, when we did this problem, we did 5 squared multiplied by 5 to the 6. Notice how we didn't actually do 5 times 5 and turn that into a 25. So avoid that temptation. So similarly down here, even though you see a 6 in the numerator and a 6 in our denominator and there's a fraction bar, you don't actually do 6 divided by 6 and turn that into a 1. Okay, the base doesn't change. It stays the 6. And all we do is subtract the exponents. We would have 11 exponents, or 11 6's left in the numerator. Okay? All right, number 7. Don't do this on yours. I'm just doing it so you ignore it. Do the A and the B. See if we have that part down. And then we'll deal with the fraction in a minute. So don't get rid of your fraction. I'm going to erase it in a second. So tell me, what do you think we get for A, and what do you think we get for the B? Let's do Brooke. What do you have, Brooke? Good. So Brooke said a squared, b to the 5th. That is correct. We're just doing 7 minus 5 is 2. 9 minus 4 is 5. So that's what we do with our exponents. These are, again, only exponent rules. So when you have numbers, these behave normally. So don't do like 10 minus 15 and be creative that way. I also don't really want you to plug this into our calculator and give me a 0.6 repeating. I don't want that to be the coefficient of these. We want to reduce this. So the 10 divided by the 15 we want to reduce. So we're just thinking of kind of what we did last chapter. What's our greatest common factor between a 10 and a 15? That would have to be 5. So each of them gets divided by 5. 10 divided by 5 is a 2. 15 divided by 5 is 3. So that would reduce down to be a 2/3. All right, so we get 2/3 and then a squared b to the bed. All right, so that's our dividing. Then, I usually have people pull out their calculator to do this. So if you have it, you could feel free. But I usually do this, tell them like, do 2 to the 0 into your calculator, do 4 to the 0 into your calculator, and see what the calculator gives you, because usually people are surprised, even though we talked about this a little bit in Math 1. But anything to the 0 power, whether that be a 2 to the 0, 4 to the 0, 6 to the 0, is always, always, always a 1. So anything to the 0 power is a 1, all the time. Here's why. In terms of, if I have 8 squared divided by 8 squared, that should be, according to our rule we just did, that should be 8 to the 0, because I would do 2 minus 2. And according to the new rule, that better equal a 1. So there's a couple different routes we could take to show this now. If I did 8 squared divided by 8 squared, isn't that really just a 64 divided by a 64? And then that very clearly is a 1. Okay? We're basically, or even over here, anything divided by itself is 1, right? So 8 squared divided by 8 squared, they're identical. Anything divided by itself would have to be a 1. So anything to the 0 power is a 1. So for example number 8, since this 0 is outside of the parentheses, that means everything inside of the parentheses is raised to the 0 power. So since everything is to the 0 power, it's as easy as it gets, that whole thing has to be a 1. Understand how that differs a little bit with number 9? There's a difference between what I have written here and if I gave you this. So if I gave you this one, that means the x and the 8 is to the 0 power. That's not what we have, however. The only thing raised to the 0 power is the x. So this is really 8 times, and then x to the 0 is a 1. And then we would add our 5. So that's really just 8 plus 5. So this should be 13. All right, so anything to the 0 power is a 1. All right, so there's 3 of our rules. This is the rule that usually causes some issues as we move along. It's called the negative exponent rule. It says for any non-zero number a raised to a negative exponent, you're going to place that power in the denominator, and then that power magically becomes a positive power. All right, so the way I usually show this, and again, if you have your calculator, feel free, but I usually do a 2 to a negative 2, and I tell people to put that into their calculator. And then they're usually very surprised when the calculator spits out a 0.25 in terms of where did that 0.25 come from? How is 2 getting raised to a negative 2 going to give me 25 cents? And it's because of this rule here. This rule is saying if I have 2 to a negative 2, it's kind of like a 7. If I give you 7, would we all agree there actually is a denominator of 1 that we don't write? It's sort of silly to, it's sort of silly to write that. It's same here. This does have a, whoa, what was that? This does have a denominator of 1. Try that again. We just don't have to write it. So what this is now saying, our rule is, take that fraction, and notice how the 2 to the negative 2 is in the exponent, or in the numerator. If I take that and put it into my denominator, the exponent magically becomes positive if it was in the numerator and I move it. And then the 1 is now in my numerator, so we're basically doing the reciprocal. Kind of think of the negative exponent as the reciprocal. We want to flip it. That then gives us a 1 on top and a 4 on the bottom. Well, 1/4 is 0.25. So a negative exponent means we need to flip it, at least that term. Here's why. So according to our rule, I'll write this over here again. We're going to do this problem 2 different ways. So according to our rule, we should just subtract these like we did before. you're going to do 2 minus 5. So whenever I divide like terms, I'm going to subtract exponents. So 2 minus 5 should give me an exponent of a negative 3. All right, when we divide exponents, you subtract. So 2 minus 5 is a negative 3. According to our rule, also put this over a 1 right now. So we know there is a denominator of 1. According to our rule, if this guy is currently in the numerator, which it is, then I should be able to put it into my denominator. I'm just going to flip it. And when I flip it, my exponent changes signs. So that then I still have a 1 in the numerator. It's not like there's a 0 there now. This should be my answer. So we combine two different rules. You subtract the exponents to get the negative 3. And then the negative 3 just means we need to flip it. So it was in the numerator. We're going to put it into our denominator. Here's the other way to now approach this. And then I don't care moving forward what your thought process is when you do these. I personally like this next rule better, but you want to know both. Write this out. This means I have 2 b's on top. B squared is b times b. In your denominator, you have 5 b's. Anything divided by itself is 1. It would just cancel itself out. So these b's cancel each other out. These b's cancel each other out. Doesn't that leave us with just b cubed into our denominator? And the only thing left over on top is a 1. This is the exact same answer that we got using those other rules. All right. Whichever your thought process is perfectly legitimate. Just make sure that we're able to do either or. All right, so number 10. If I had a calculator, I would tell you to plug this in, because most people don't believe this initially, what this value is. I promise you, if you do 2 to a negative 3, it's going to give you 0.125 as a decimal. I don't want the decimal value. We want the fraction value. We want this to be simplified. And that is because currently this has a denominator of 1. So I'm going to flip it. I'm going to take the numerator, put it into my denominator, and then that 3 magically becomes a positive exponent. And then now we would just have the 1 in the numerator. And what that fraction now leaves us is 1 over, and then if I do 2 times 2 times 2, that should give me 8. And if you threw 1 over 8 into your calculator, it will also give you this 0.125. Right? Okay, next one, same thing. Let's imagine there's a 1 there, because there is, we just don't write it. If I have the negative exponent, we're going to flip our fraction. So take the negative 3, put it into your denominator, and the exponent becomes a positive 3. The 1 is now your numerator. So when we simplify this, there's still a 1 up here. Be careful with the negative 3 cubed. That means I have a negative 3 times a negative 3 times a negative 3. When I do the first two, a negative 3 times a negative 3 is 9. When I multiply those together. And then the 9 times a negative 3 should be a negative 27. So we should get 1 over a negative 27. Okay. All right. Next one. This is called a power raised to a power. So that means I have an exponent. Here's my exponent. That is also getting raised to another exponent. And what you will see you're supposed to do, both in words here and in the way this is written, we want to multiply in that case. So a power getting raised to another power, we want to multiply the exponents together. So for this one, it's as simple as doing 2 times 8, which is 16. The reason for that is we have 8. Remember, the exponent implies repeated multiplication. I have 8 of these guys. I have 8x squareds. And if we then use our old rule, oops, how many is that? 1, 2, 3, 4, 5, 6, 7, 8. Oops, sorry. If I now do 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, it will give me that exponent of 16. All right. So number 13, just an exponent to an exponent. You're going to do a negative 3 times a negative 4 positive 12. All right. All right, then our last one, I believe. Yeah, kind of. Power over products. What this is simply saying, if I have a power of more than one term, so if we now look, we have 4, x cubed, y, z, all of that's getting raised to that power. That just says the power is going to go to each factor within that parentheses. All right, so go to number 14. Do me a favor, do not follow what I'm going to do now. Do not cross out your 4. Leave that 4 there. We're just going to deal with the variables. The y has a power of 1. The z has a power of 1. Just like we did in the previous problems, numbers 13 and 12, if I have a power raised to a power, I should multiply those exponents together. So this is really the 3 getting multiplied by 3 to give us a 9. Then the exponent of 3 multiplied by that exponent should give, I'm sorry, that's an x, right? And then the y should have a power of 3. And then the z has a 3 times a 1. The z has a power of 3. So that just means each term in the product gets raised to that power. Probably the biggest mistake I see made is with this type now. Because it's clear we're going to do 3 and 3, and the z, and the y. But the 4 is also getting raised to that power. And it's really, really, really easy, so don't be this person, to think this is going to be a 12 right here. All right? That's not a 12. It's the exponents we're multiplying. It's still 4 cubed. So we're doing 4 times 4 times 4. The first 2 4s will give us a 16. And then the 16 multiplied by that last 4 jumps us to a 64. So 4 cubed should give us 64. All right. Okay, real quick, cross out this one. We can get this done. We got 2 minutes this time, Mr. Kubitz. Do this for me. 2x cubed, y to the 4th, z squared, and then raise that all to the power of 3. Let's see what we get.
Is that a 4 above the 1?
It is a 4, yeah, thank you. All right, let's see what we got here. We got 1 minute left. I would hope the x, y's, and z's are good. We talked about how a power to a power we simply multiply. So you're going to do the 3 times a 3 is 9. The 3 and the 4 should make a 12. And then the z has the 3 and the 2 to make a 6. Very, very careful that you don't throw a 6 right here. Okay, it's 2 cubed. That's 2 times 2 times 2. This should be an 8. All right, 2 cubed is 8, and then everything else you're doing exponents and exponents, you're multiplying. All right. Okay, with that, bell's going to ring in about 10 seconds. So no homework or anything. We're obviously not through all this. Bring this on Wednesday. Enjoy your day off tomorrow. We'll pick up from here Wednesday, and then you should be able to do some homework on that Wednesday night. All right? Okay. See you guys. Have a good day. See you on Wednesday. And stop recording.